So let us compare the object-oriented analysis that we discussed earlier with the structured analysis or structured design or SASD, which is the traditional approach of software development based upon the waterfall model. So this is the waterfall model. The waterfall model contains different phases, which starts with requirement analysis, system design, implementation, testing, deployment, and maintenance. Now, each phase must be completed before the next phase begins. No overlapping in the phases. So it means once you are completely done with requirement analysis, you can now start with the system design. Only if system design is 100% finished, then you can proceed with the implementation. No overlapping in the phases. One has to be done first before proceeding to the next. Now, so what do you think is the risk of the waterfall model? As for the unified modeling language, it is a graphical language for object-oriented analysis and design. It gives a standard way to write a system software's blueprint. It is used to depict the structures and the relationships in a complex system. All right. So in this example, we use boxes like Python classes. Then blue is for analysis and design. The green analysis, then application. The arrows contain the data flow, data in, data out, and then the workflow, process, configures, constructs. Okay, so this is an example of unified modeling for a library management system. So the classes include are book, the author, book item, then we have library, member account, librarian, account status, book status. Mm. All right. So the classes have a connection between some other classes. All right. So classes are interrelated. Like the book item extends book. Whatever book, whatever attributes or properties each book item has are also in the book class in here. Right? Then we do have the librarian class, for example. Librarian relates or librarian has a relationship with the book item in a case that the librarian updates the book item, the book information. Then member account is connected to book item because a member borrows a book and a member as well may reserve a book or a book item. Then a member account goes to the library and library contains the book. So these are some of the relationship between the classes. For the systems and models in UML, we do have a system, which is a set of elements and often divided into subsystems. So in this example, car is a system which is divided into ignition subsystem, brake subsystem, and cooling subsystem. Okay, the next one is the model. The model is what the complete abstraction of the system is. So we don't normally see this in a car, but it is present. And then the last is the view or the projection of a systems model. So in our case, we only see the car as this is, but we don't see the complete system or subsystems included. The conceptual model of UML encompasses three major elements, which includes the basic building blocks for the things. We do have the structural, behavioral, groupings, and annotational. We do have the relationships, dependency, how are objects dependent with another, the association or their relationship, the generalization, and the realization. Next, for the diagrams, the graphical representation of a system. The next element is the rules. There should be rules for names. What are names that are acceptable and names that are not? The scope, the visibility, the integrity, and the execution. And the common mechanisms. What are these mechanisms? Again, the specifications, the adornments, common divisions, and extensibility mechanisms. Now, so let's talk about concepts of object-oriented. So earlier we discussed about this as an example, but let's see this in detail. The top section containing the name of the class. For example, the class name is Circle. So, the middle section contains the attributes. What are the attributes of the circle? So, it has the x coordinate, the y coordinate, and the radius. Next, the bottom section representing the operations of the class. So, a circle will be able to help you find area, find circumference, and the scale. Okay, so this is a class. Again, it has class name, attributes, and operations. How many classes do we have in here? We do have 5. The order line, the order, customer, personal customer, corporate customer. Now, the order is the class name. Date received is prepaid, number and price are the attributes. Dispatch and close are the operations. Okay? So since order is a transaction, it has operations. Looking at the customer as a class, customer has attributes which are the name, the address, and credit rating. But it doesn't have what? Operations. Customers will feed and receive but not do anything as a transaction. The same with the order line and the personal customer. So these are called like uh, simple classes. And we do have the transactional. Aside from order, we do have the corporate customer, which has contact name, credit rating, and credit limit as the attributes and remind as the operation. Now, these are the objects naman. The top section contains the name of the object. Object name is the class name, and the bottom section represents the values of the attributes. Next, we do have naman component. This is the physical and replaceable part of the system that conforms to and provides the realization of a set of interfaces. So in this example, the order processing has several elements. It has new orders and customer system, and then the interface or the collection of methods of a class or component. So it specifies the set of services that may be provided by a class. So in this example, we do have the the customer and the order and the delivery as classes. And what are the methods or the services that can be attached to them? The online ordering and the shipping. For example, for the delivery class, it for the delivery class, the services connected to it is the shipping. Then for the order, it can have the order online or the online ordering, and the customer orders online as well. Then the package, this is an organized group of elements and may contain structural things like the classes, components, and others. Okay, so we do have the object-oriented concepts, and then we do have the relationship. So this tells the type of relationship between objects. So if you're going back to the symbols being given kanina, there are several ways to write the arrows or the flow of the data. And these are not just something for you to draw. Okay, so there are ways to write the flow of data, but it has meaning. So for example, the broken arrow and the broken arrowhead is the dependency. One object, sorry, one class is dependent to another class. The straight black line is the association. And then the one with the arrow, direct association, and so on. So we will discuss that later on.